Okay, hi everybody. Sorry that I can't be in class today, but I've prepared this presentation on tropospheric ozone. So here we go. So ozone itself is a naturally occurring chemical that exists in two parts of our ecosystem: the stratosphere, which is the upper layer, and the troposphere, which is the lower layer. So in the upper layer, which we all know colloquially as the ozone layer, actually protects life on Earth from the sun's ultraviolet radiation and acts as a buffer between the sun's radiation and the lower parts of our atmosphere. The problem, though, is at lower levels. Troposphere. In the troposphere, ozone is a greenhouse gas and an air pollutant that's a major component of urban smog. So in big cities where there's low-lying smog, that is tropospheric ozone. And like everything we're studying this week, it's a short-lived climate pollutant, and it only has a lifetime of a few hours, and at most up to a week. So tropospheric ozone actually doesn't have a direct emission source in itself, but rather it's a secondary gas that gets formed from the interaction of sunlight with other hydrocarbons, like methane, nitrogen oxides, which are both commonly emitted from man-made sources like vehicles or fossil fuel plants. So why it's dangerous, and the science behind why it's dangerous, is because not only does it contribute to global warming and surface temperatures, but it also impacts weather patterns such as cloud formations, precipitation levels, and changes the way the atmosphere circulates as opposed to its natural state. And it's not only harmful to weather patterns, but it's also harmful to, it also has health risks to humans, animals, agriculture, and ecosystems. So while it only spends up to a week in the atmosphere, it still causes 1 million pollution-related deaths every year due to respiratory illnesses, and millions more on top of those 1 million deaths, chronic respiratory diseases. It also is toxic to many plants and can harm agriculture. So from 2010 to 2012, for example, increased amounts of ozone reduced the global yields of wheat, rice, and maize by 227 metric tons. And they attributed that to increasing levels of ozone in the lower part of our atmosphere. Okay, so that is it for the background in science. So I'm going to move on to some of the existing strategies that organizations and governments are using to combat lower level ozone, and also some policies surrounding it. So strategies that exist right now to prevent the formation of tropospheric ozone are primarily based on methane reductions and cutting the levels of man-made atmospheric pollution. And these, I'm sure, will be outlined in greater detail by my classmates presenting today that are focusing specifically on methane. But the main areas to reduce methane are agriculture, to improve practices in the agriculture sector, fossil fuels, and waste management. But in terms of tropospheric ozone itself, in terms of what's healthy, what's a healthy or what's a baseline amount of safe, I guess, for humans to be breathing lower level ozone, is the World Health Organization puts it at 50 parts per billion and some governments actually do have, I guess, their own baselines or limitations that exist, but they're all the ones that I've found that actually exist are higher. Like the threshold is higher than the 50 part. So many European governments have theirs set at 60. In the U.S. there's a set at 70, and in China it's set at 75. But often these governments don't even police their own regulations, and this is for a couple reasons, but one of them is because it's difficult to regulate because ozone itself isn't itself a greenhouse gas that gets emitted. It just comes from a chemical reaction with other parts of the atmosphere. But further, the two largest factors that get in the way of improving ozone levels and reducing them are, one, a lack of data availability, and two, like I mentioned, the fact that ozone comes from interacting with background sources, or precursors as they're known as. But there are strategies and there are policies that do exist that are combating ozone. For example, in 2000, the U.S. and Canadian governments got together and committed to address transboundary ground level ozone by reducing emissions of nitrous oxides and other volatile organic compounds that produce lower level ozone. And Mexico has been doing something similar since 1995. And in the Americas, the Intergovernmental Network on Air Pollution for Latin American and Caribbean Exchanges, the Intergovernmental Network on Air Pollution for Latin America exchanges technical and policy information among environmental ministers, and they do that so that they can harmonize their own strategies. And there's a lengthy report that came out that I can link to as well. In the U.S., here's a map that just shows places that exceeded the the limit of ozone that is allowed in the lower level of the atmosphere. And you can see that it's really concentrated in California and the Northeast, where there's just a higher density of people and industry. But one thing that has happened in the U.S. is there was a court case that I found called Clean Wisconsin versus the EPA, which was in 2020, so 2 years ago. It was during the Trump administration, or at least the litigation began during the Trump administration. And in that, the U.S. Court of Appeals held that the EPA must act expeditiously as possible to adapt ozone non-attainment or non-formation designations, and they have to base their standards based on science, not political maneuvering. And a little aside, it's a bit unfortunate that the EPA needed a court to tell them that they should be using science to base their policies on instead of political maneuvering, but this is the world that we live in. And then also, I'm sure that everybody else came across this organization in their research, but the Climate and Clean Air Coalition had lots of good information on their website about all the different short-lived climate pollutants, but they exist to help their partners and stakeholders create policies and practices that will hopefully deliver substantial reductions in short-lived climate pollutants. And I was not actually able to find any work they're doing currently in the Americas, in the South America or Central America, related specifically with tropospheric ozone, but they have many ongoing projects related to other short-lived climate pollutants. So in conclusion, tropospheric ozone is an extremely dangerous short-lived climate pollutant that has to be addressed. The challenges of detection and it only occurring when sunlight reacts with existing precursors are real challenges, but governments and environmental protection agencies have the power and capabilities to improve ozone levels and reduce them. So we want to see them doing that. So thank you, and sorry about the recording, but I look forward to discussing our project and learning more about what you all presented about next week. Thanks.